I want you to picture this. You're standing outside on a clear night. No city lights. Just you, the dark, and a sky absolutely packed with stars. Someone hands you a telescope, nothing fancy, and they point it at a bright, steady dot near the horizon. You look through the eyepiece, and there it is, Saturn. Those rings, stretching out on either side of the planet like halos, like something out of a painting that's too beautiful to be real. You can almost feel how massive they must be. And here's where it gets strange. Those rings span roughly 282,000 kilometers across. That's almost the distance from the Earth to the Moon. Enormous, staggering, almost impossible to wrap your head around. But here's the surprising truth. If you could slice through those rings and look at them from the side, they'd practically disappear. In some places, the rings are only about 10 meters thick. 10 meters. That's the height of a 3-story building. Something wider than most of Earth's geography. Thinner than a city block is tall. It looks like a mistake. It looks like the universe forgot to finish the job. But it did not. Today, we're uncovering why Saturn's rings are almost impossibly thin, how the physics of orbital mechanics actually forces them into this shape, and why this razor-thin structure is one of the most elegant things in the entire solar system. To understand Saturn's rings, we first have to look at what a ring system even is, and why keeping one together in space is an almost absurd challenge. Here's the problem. Space is not a gentle place. Everything out there is in motion. Everything is being pulled, pushed, tugged by gravity from a dozen different directions at once. Before astronomers really understood orbital dynamics, the rings of Saturn were genuinely baffling. When Galileo first spotted them in 1610, he thought Saturn had ears. He literally wrote that the planet appeared to be triple-bodied. He had no framework for what he was seeing. And for decades, nobody did. Scientists debated whether the rings were solid, like a giant flat disk of rock spinning around the planet. If that were true, the physics would be catastrophic. A solid disk that size would be ripped apart by its own rotation, the outer edges moving too slow, the inner edges too fast, tidal forces tearing the whole thing to pieces within hours. The idea of rings surviving in space at all seemed almost impossible. A chaotic, swirling mess of particles hurling around a gas giant. By all rights, that should spread out into a cloud. A haze, not a flat, elegant, paper-thin structure. So how does Saturn do it? Let's start with the raw material. Saturn's rings are made mostly of ice and rock. Chunks ranging from tiny grains the size of a grain of sugar all the way up to boulders as big as a house. Billions and billions of individual pieces, all orbiting Saturn at different speeds. And here's the key thing. They're not just floating randomly. Gravity has sorted them. Think of it like this. Imagine you're spinning a bucket of water on a rope above your head. The water stays in the bucket because of centripetal force. The motion pushing outward balances the force pulling inward. Stop spinning, and the water falls straight down. Every single particle in Saturn's rings is doing exactly that. Each one is in its own perfectly balanced orbit, moving fast enough to not fall into the planet, not so fast that it flies off into space. It's a constant negotiation between gravity pulling in and momentum pushing out. Now, here's where the thinness comes from. Orbits, by their nature, want to be flat. When you have billions of particles all orbiting the same body, they inevitably collide with each other. And every collision is a tiny negotiation. Particles moving up or down, out of the flat plane, get nudged back. They crash into other particles moving in the dominant direction. Over millions of years, those out-of-plane particles get canceled out, absorbed, corrected. What's left is only the particles that were already moving in the flattest, most efficient path around the planet. The plane of the orbit becomes thinner and thinner, like a coin being hammered flat by millions of tiny hammers. But gravity alone does not explain why the rings stay so sharply defined at their edges. If it were just gravity and collisions, you'd expect the rings to slowly drift outward, to blur at the edges like watercolor paint on wet paper. They do not. And the reason is one of the most fascinating things in planetary science. Shepherd moons. Saturn has small moons, some only a few kilometers across, that orbit just outside the ring edges. Moons like Prometheus and Pandora, sitting like quiet little border guards on either side of certain ring bands. Here's how it works. Any ring particle that starts drifting outward toward a shepherd moon gets a gravitational nudge. The moon's gravity pulls on it, and in a weird twist of orbital physics, that pull actually slows the particle down, causing it to drop back inward, back into the ring. It's like a bouncer at a door. Every time a particle tries to sneak out of the ring's edge, the shepherd moon sends it right back. This is why some of Saturn's rings have edges so sharp they look almost cut with a knife. Not blurry, not fading, just a clean, crisp boundary maintained by physics, running for hundreds of thousands of kilometers. Now, and this is where it gets genuinely mind-bending, the rings might not be ancient. For a long time, we assumed Saturn's rings were as old as the solar system itself. 4.5 billion years old, a permanent feature. But data from NASA's Cassini spacecraft, which spent 13 years orbiting Saturn before diving into the planet in 2017, told a different story. The rings are young, cosmically young, possibly only 10 to 100 million years old. That means when dinosaurs were roaming the Earth, Saturn's rings might not have existed yet. And they're disappearing. Ring material is constantly raining down into Saturn's atmosphere, pulled in by the planet's magnetic field. Scientists estimate the rings could be completely gone in another 100 million years. We are, in cosmic terms, catching Saturn mid-transformation. We happen to evolve and point telescopes at the sky at the exact window of time when those rings exist to be seen. That's not luck. That's perspective. And it should change how you feel about looking up at that pale dot in the night sky. So, if the rings are temporary, held together by precise physics, watched over by tiny moons, and slowly fading, why are they still so impossibly, perfectly flat? Because flatness is the default in orbital mechanics. It's not the exception. Flatness is what happens when chaos finally resolves itself. It's what happens when every particle finds its place. The thinness is not a flaw in Saturn's design. It's the signature of physics working exactly as it should. So the next time you see a photograph of Saturn, and you will because it's everywhere, do not just see the pretty planet with the rings. See the mathematics. See billions of individual pieces of ice and rock, each one locked in its own precise orbit, shaped by billions of collisions into the flattest structure they could possibly become. See the shepherd moons, silently patrolling the edges, keeping every boundary crisp and clean. See something that is, right now, in the middle of disappearing, and that we are extraordinarily lucky to witness at all. That razor-thin profile is not a limitation. It is not a cosmic accident. It is what order looks like in space. It is what happens when gravity, motion, time, and collision all reach an agreement. And the fact that it looks like a painting, that's just a bonus. Thanks for spending this time here. I hope this explanation added a little clarity.